Okay, so I think we are ready to start this talk. So first of all, I'd like to thank you all for coming, because I think that you were not expecting me to be here. Actually, I'm replacing Eric, who couldn't make it to be here. So I'm not going to have the exact same talk that he was planning to do, but I will talk about Android. So just a quick introduction. Who am I? My name is Cyril Mottier, so I'm basically an Android Google developer expert. So it's a quite new program at Google that rewards some people from the community that are experts on some technologies of Google. And I'm an expert on Android. So what it means that it means that basically I'm not a Google employee. And as usual, I have to put a disclaimer at the beginning of that kind of conferences, that is, what I'm saying here is not approved by Google, it's only me talking about Android. So you can find me on Twitter, at Cyril Mottier, or on my personal blog, where I usually write about Android-related stuff on cyrilmottier.com. Just rapidly, I can also talk about the company where I'm working at. But I'm sure you know about it because you've used it to come to Devox if you're traveling from France or Germany. The company is called Captain Train, and what we're doing is selling train tickets in a very easy way. We're trying to revolutionize the way you are traveling with the train and how you buy your train tickets. So I can talk all day long about this service, but I think the best way for you to test it is just to try it out. So you go to captaintrain.com and then try it out, and you'll see that it's really, really awesome. You can see here a screenshot of the website, so it's very clear and very easy to use. So today I would like to talk about Android Drawables and why. Well, when I studied Android development, I discovered Drawables, and I was really happy about them. This notion is very, very great. And actually, I've also noticed that lots of developers do not really know about what Drawable can do. And in this talk, my first goal is to show you that Drawable are more than what most people think. And in order to understand that, I think it's necessary to start with a brief definition of what a Drawable is. So here is my definition of a drawable. It's an abstraction of an entity that can be drawn onto a canvas. So I know that this is not the best definition ever, because using words such as abstraction or entity in a definition is kind of lame. But let's give you some example. For instance, something that can be drawn is a color, a shape like a rectangle or a circle, or even a bitmap. So all of that can be drawables. And contrary to views, actually drawables are way lighter, way more efficient when you need to render them on screen, because they don't deal with the measure path and the layout path that you have to deal every time that you're using a view. So whenever you want to draw something on screen, it's probably better just to think about drawables and not to start using a new view or creating a custom view. So let's start with a quick introduction to what Drawable has, what are the properties of a Drawable. So I've taken a nice tiny ghost like this one, and this tiny ghost is defined by a bounding box. And this bounding box in the Android SDK can be retrieved thanks to two methods, which are the getIntrinsic_width and the getIntrinsic_height methods. So they basically returns the number of pixels for the width and for the height of your drawable. So this is what is called the bounding box. But whenever you want to draw a drawable on screen, so onto a canvas, the drawable won't actually, draw at its exact size. It will use the bounds of the drawable. And those bounds may be larger or smaller than the actual drawable. And this is, for instance, what this ghost will be drawn into the bound. So you can see that the image is scaled up so that it fills the bound. And this is a contract of a drawable. A drawable always fills its bounds. But the drawable also have some other nice properties that are really, really useful when developing Android application. For instance, it can have a state. A state is basically a way to change the appearance of the drawable based on this state. And this state is, most of the time, you can have a state for the press state, or the focus state, or the window focus state. So all of those states are actually bundled in an area of integers, and depending on this area of integers, or this set of state, the drawable can change its appearance. A drawable can also have a level, and level is mostly used to change the appearance of the drawable in a way that it is not entirely displayed depending on the current level. And the level is most of the time, actually, by contract, a number between 0 and 10,000. So you can use, for instance, set level just to change, the current amount of visible portion of the drawable that is visible. This is, for instance, used with, the tiny bars that are expressing the number of, the quality of the signal you're receiving from the 3G network. So these are some nice properties of drawable. But actually, when you want to use it, you can do that in two ways. From XML, of course, just by doing this. So here, what I've done is, in my XML layout, I've created an image view, which has an ID, which is here basically image view. Obviously, you have to set some layout width and height, and here they are set to wrap content. And finally, I've used the Android source XML attributes, just by using the Android way of pointing to resource, which is @drawable/ the name of the drawable. Here, IC share. So just by doing that, you are actually using the IC share drawable inside as the drawable as the source of your image view. Obviously, you can also do that from the Java code programmatically. And this is done very easily too, just by retrieving a reference to your image view, and then setting a drawable to your image view using the setImageResource method. And that's pretty much it. There is nothing more to say about drawable. That's what people think. And that's why I said at the beginning, most people think that drawable are just that. Actually, they are more complex than that, and we'll see later that you can do a bunch of things more powerful than just loading them from XML or from the Java code. And here is a great example of that. So let's continue with how drawables are actually loaded by the system. Actually, when you want to load a drawable, you will call a single method. And this single method is provided by the framework, and this single method is actually a very common one, which is available in the android.content.res.resources class. And this method is drawable. It returns a drawable, and it's named getDrawable, and it takes an int. So the int that you passed as an argument is basically a reference to this, to the drawable you want to get, and the drawable that is returned is the drawable that you want to get. But what is this drawable actually? Because drawable means, well, something that can be drawn, but it's not really, precise. So basically, if you have a look at the class hierarchy, here is what you have. Drawable is actually an abstract class. So just by making it abstract, the SDK, in the SDK, it basically means that it is made for extension. So a drawable is something that can be extended, and you can find a lot of concrete example of drawable inside the Android SDK. Some of the best examples, of course, are the color drawable, which is just a drawable that draws a color, and a bitmap drawable, which is a drawable that draws a bitmap. And you can also have some more, I would say, complex, but composited drawables, such as the drawable container, which is a drawable that contains all the drawable and will display those drawable in a very special way depending on the subclass. For instance, you can find the stateless drawable, which displays a drawable depending on the current state, as I said at the beginning, or a layered drawable, which is the equivalent of the frame layout, which will completely draw all of the drawable inside it and stack them up directly on screen, just like a frame layout would do. And all of that is what we call the class hierarchy of the drawable. And actually, if you look attentively to that, you will notice that it looks very similar to another class hierarchy in the Android SDK, which is the view class hierarchy and the view group class hierarchy. You have the exact same pattern where drawable would be view and drawable container would be view group with the composite pattern like this. So it's very, very, very common in the SDK to have this kind of architecture. It's just like Vue, as I said, it's made for extension, so you can obviously create your own custom drawable. You don't have to use and reuse always the same kind of drawable that are provided by the SDK. And if you look at the history of the drawable class, you will notice that it's extremely stable. It almost hasn't changed since day one, since Android 1.0. So as I said, there is only one method. So we know how what the drawable can be, the return drawable of the get drawable method can be, but we don't actually know about the implementation of this method. So let's look at the implementation of this method. So whenever you're trying to load a drawable on Android, you will go through this graph. First, the system will try to look at the extension of your file. If it ends with .xml, then it will inflate the XML to create the associated the associated drawable. If it's not, well, the system will try to decode the image directly from the stream. What it means basically here is that if the image is not actually an image, so for instance, if you're trying to get the drawable on an MP3 resource, you will have an exception because the system cannot decode the image. And finally, when all of that has been done, the drawable is returned. So quite simple. You all know how it works now. It just looks at the extension of the file. If it's XML, it decodes the XML. If it's not, it tries to decode the image associated to the pointing file. So let's play now that you know how it works. So I've created a very simple example code. And so what I'm doing here is basically I've overridden onCreate, so in a fragment or in an activity, it doesn't matter actually. And in this onCreate method, what I do is I get a reference to the resources, and then I get two drawables, which are called here D1 and then D2. And all of those drawables both of those drawables are actually pointing to the exact same resource, which is r.drawable.ic launcher. And then what I do with those drawables, I basically just print them out to the logcat. And do you know what may happen to that? Well, if you look at the output of this, you will end up with something really similar to that. So basically, it displays that what I have is a bitmap drawable, which is great because I'm just pointing to a bitmap. But if you look more attentively to the bitmap drawable, you'll see that there is two different drawables. So the first time I saw that, actually, I ended up like that. I mean, what the fuck is that? Does that mean that whenever I'm trying to load the exact same resource, Android will decode the image twice and take twice memory as needed? This was not, possible. I mean, it was not optimized from my mind, from my point of view. So I started to look further, and then actually I noticed that getDrawable always returns a new drawable. But there is a but, actually. And this is where the system is way more efficient than just loading drawables and loading resources from the resources of your application. And if you change the code that I've explained earlier, just by displaying something else than just the drawable, but a notion that is called the constant state, then you have something different. So here what I'm doing is basically the same. I'm just displaying something else, which is the constant state of each of those drawables. And here I will notice that the object that I'm printing out is not a drawable, of course. It's a bitmap state. And this bitmap state is actually the exact same for the two drawables. So that basically means that whenever you're trying to load the exact same resource, Android will share the constant state of all of these resources, but creates a new wrapper, a new drawable wrapper around this state. And this is why drawables always share this constant state. And this is also why when you're loading the exact same bitmap from your resources, you don't have two exact same bitmap in memory. Actually, this is the exact same one bitmap that is shared between two different drawables. And yeah, this is fine because you are developing for Android, which is a constrained environment, so you don't have a lot of memory. And just by doing that, you can win against the memory. And actually, this is really awesome because this is done at the application level, but also at the framework level. So if you were at Romain and Chet presentation yesterday, they talked about a process called Zygote, which is basically the first process that is started when you are booting your device. And in this process, Android will load lots of classes and framework resources, such as, for instance, the bitmaps that are used to draw the buttons, the checkboxes, the sig bars, and all of that stuff is loaded into Zygote. And when you want to start your own application, Android will fork Zygote and then start a Dalvik machine inside the Zygote process. And just by forking Zygote, it means that all of the resources that are from the framework are actually shared among processes. So the button bitmap, for instance, is created only once in memory and reused for all other processes. The constant state is, as I said, it's awesome, but it may be a problem sometimes. Because let's say, for instance, you have a list view with lots of stars for each item of this list view, and you want to fave or to store one of these items. If the constant state is the same for all of your drawables, well, basically, when you are starring one, all of the drawables will be stared at the same time. So this is something you don't want to. So you can call, obviously, a new method, another method, which is called mutate. And what this method will do is basically to look at the mutate state. So if it's already mutated, it will do nothing. If it's not, it will copy the constant state and then use this constant state as the constant state of this drawable. And this is where you end up with like this, like a boss. Everything is working, and this is perfect. So let's continue with some nice gotchas about drawables. Some of the things that lots of people doesn't know about. The first thing to know about drawables is that they can be instantiated via XML. Here is the exhaustive list of all of the drawables that you can create by XML, using XML. So if you're using a selector, you will create a stateless drawable. If you're using the level list tag, you will create a level list drawable, and all of that stuff. The only one which is kind of weird is the shape tag, which creates a gradient drawable, and in this SDK you have the shape drawable. So shape doesn't create a shape drawable, it creates a gradient drawable. So I don't know why it is that way, but it is. So you just keep that in mind. When creating a shape, you don't have a shape drawable. So all of those XML tags can be used by your application to create some drawables. Actually, there is a funny one, which is not public, because you can use actually another tag, but I won't give its name, but it creates a drawable that is hidden. So it's quite nice, because normally you shouldn't use it, but you can create it just by using a special tag, which is quite funny. And finally, you can obviously try to use another tag. And if you do, well, you will end up with a resource.notfound exception. And you will always end up with that kind of exception, which can be kind of boring sometimes because, and disturbing also, because if, for instance, you have made a mistake in your XML implementation of your drawable, you will always end up with resource.notfound exception, even if there is just one quote missing. If it's a parsing exception, you will end up with this. So always look at the cause of this exception. It may help you to debug your application. And here is the big difference between what you can do with views and what you can do with drawables. With views, you can use your own custom tags, actually. If you're using the complete name, the name of the view, the framework will actually instantiate your own views just by using the name that you've given in the XML file. Well, you can't do that with drawables. You can't create custom drawables and inflate them via XML. And this is something that is actually can be easily understood when you know that drawables can be shared among processes. So basically, having that similar feature would involve that when you want to inflate a drawable in your own process, you create this class in your own process, but if you want to share it in another process, this process doesn't have access to the code associated with your drawable. And because of that, you can't do that. So the Android team has decided not to be able to inflate your custom drawables. And for instance, sharing drawable can be used, for instance, for the launcher. The launcher will try to get the reference to your icon on the launcher, or if you also have some widgets in your application, all of this is actually extracting from your own process and displayed in another process. So let's continue with some nice features that you may or may not know about. The first, I think the most used drawable in Android development is probably the bitmap drawable. So most of the time, you just get the drawable to the resource, and you get a bitmap drawable, as I shown in my previous slides. But actually, you can also create the drawable from XML. And if you do that, you just use bitmap, the bitmap tag, and you set the source to the appropriate source. And if you do that, well, actually the code is kind of, you're spending time to write this, but it's not really useful because you can get the drawable directly. But if you do that, actually you can also add some other properties to bitmap drawable. And this is where drawables are way better than just primitive types such as bitmap or color, which is an int, because you can do something more on top of those primitive drawing objects. If you do that, and remember what I said at the beginning of the presentation, you will notice that it won't draw like this. Actually, the bitmap will fill the bounds that have been set to the drawable. So this is what will be drawn, actually. This is quite blurry because you're basically scaling a very tiny image. But what you can do, thanks to the bitmap tag, and just by declaring everything from XML, is to set a gravity, just like you would do for a frame layout. Just by setting a gravity, the bitmap, the associated bitmap with this bitmap drawable will be drawn in the center of the bands. So you can set the gravity to bottom left and all of that. So the exact same gravity that you can use with frame layout. If you want to, you can also use another property, which is the tile mode. So tile mode is basically you repeat the exact same pattern over and over again just to fill the bounds. If you do that, you can have this, and you probably remember that the old version of the Google Play Store was using it for the background of the action bar. You can also do some funky stuff like this, just by using the mirror mirror value for the tile mode attributes, which is, it can be sometimes useful, but it depends on the application that you're developing. If you want to do something back in the 80s, I don't know, it's okay. Another interesting things to do from XML is to create some selectors. So basically, some drawables that will change based on the fact that the user is, pressing the screen or not. So here, the main case of that is to use as a background of each item in the list view. So here I have a list view, and in this list view, what I'm doing basically is a selector that when the color is the item is pressed, then I want to display the highlight color as the background, and if it's not, I want to draw nothing, so I just draw the transparent color. If I do that, if I use that as the list selector on my list view, everything will be okay on Jelly Bean. It will display something like that. But if I use the exact same drawable on Gingerbread, this is what you will have. And this is actually quite disturbing. And at the first time when I had this behavior, I was like that. What the fuck is going on? And actually, this is because color drawable was buggy prior on Econ. It was not respecting the bounds. It was not filling the bounds. It was filling an area which was actually the entire canvas. So if you're targeting, if you're developing for pre-on Econ, it may be a problem. So if you're only developing for post-on Econ, it's not a problem anymore because the bug has been fixed. But if you're still targeting Gingerbread and all of that stuff, then you have to come up with a workaround. And here is one, just by using a gradient drawable with a solid color. So instead of using a color drawable, what you can use is the shape tag, and you set the shape to rectangle, and then you set the solid color to the color that you want to use at the background when pressed. And sorry, and obviously I haven't changed the transparent color because I actually don't care because it's not visible. But you could also use a shape drawable if you want to. And if you want more about all of the XML attributes that you can find for all of the drawables, you can go to the android.graphics.drawable package. For each class, you have a header with all of the properties that you can set. Another one that I have not talked about in this talk is the size property, which can be quite useful because some drawable have actually no intrinsic size. For instance, a color doesn't have a size because it's, it doesn't have a size. So it always returns -1 on get intrinsic width and get intrinsic height. So if you want to set a size to, for instance, a shaped gradient drawable, so the shape tag, you can use the size attribute. And this may be quite useful when you are wrapping content on the drawable. So let's continue with some advanced drawable usage. And what I mean by advanced drawable usage is when you're creating some custom views, because when you're creating some custom views, you may need to display some drawables or let some people, style your own drawable, but just by setting their own drawables. And using a drawable in your custom view is actually pretty easy. You just have to add some lines of code, a few lines of code to your custom drawable. So here is an example of that. So what I've done here is I've created a drawable view, which extends view. So it's a very basic one. It has one main method, which is the setDrawable method, which takes a drawable, of course. And if the drawable is different from the previous one, then I keep a reference to this new drawable. And if this new drawable is not null, then I set the bounds of this drawable. And this is, do not forget to set the bounds of a drawable, otherwise it won't be visible. And this is something that lots of developers are missing most of the time. And finally, what I do is in onDraw, I call through the super.onDraw. Actually, this is not useful because I'm just extending view here. But if you are, extending text view, for instance, you have to do that. Otherwise, the text won't be drawn. And if my drawable is not null, then I just call the draw method on it, and I pass the Canva to it. And the drawable will draw itself on the Canva. That's it. You're creating a custom view that is using a drawable. So in order to test it, one drawable that I most of the time use is the animation drawable. And if I use that here in my custom view, chances are you will end up with this. I mean, you will completely, it will drive you mad. I make that, and I apologize to my display. Actually, the answer is that a drawable may need to redraw itself, to invalidate itself. And this is not a behavior that is up to the drawable class nor the drawable class hierarchy. It's something that is up to the view hierarchy. So how can a drawable notify the view that it wants to redraw itself? Well, the answer is quite simple. It's an interface that is called the callback, which is an inner interface of the drawable class. And this interface actually contains 3 methods. The first one is the invalidate drawable. So the invalidate drawable is a method that a drawable can use, to call back someone that it needs to redraw itself. The scheduled drawable is a callback that the drawable will use when it wants to schedule something at a future time. Here, a runnable is the runnable that will be executed at the when time. And obviously, you can also, from a drawable point of view, unschedule a drawable or a runnable, that you've previously scheduled. And one good thing about this interface is that most of the time you don't need to use it, because if you look at the view class, it already implements it. So the view class that is provided in android.view.view implements drawable.callback and make all things way much simpler just by creating and providing a new method, which is verify drawable. So this method is basically a method that has to return a Boolean, and this Boolean needs to be true if your view is managing the drawable. So let's continue, let's go back to the example. So what I do here is basically I'm unregistering from the previous drawable when I'm saying a new drawable, because I don't want to notify I don't want the old drawable to notify myself if it's not attached to it right now. Then I register the current view as the new callback just by using the setCallback method and passing this, because this is here a view. And finally, I override the verify drawable, and this is where all of the magic happens. Because what I do here is that I call through the super implementation, because maybe view has some background, some drawable, such as the background that it is dealing with. And if this returns true, or who is equal to the drawable I'm managing in my drawable view, then I returns true. And in this case, invalidate calls and scheduled calls and unscheduled calls will be actually, dealt by the view you're creating, your custom view. So whenever you're creating a custom view and using drawable, always override verify drawable. Otherwise, none of the animated drawables will work. And by animated, I mean animate drawable, transition drawable, all of that kind of drawable won't work. Drawable are also very, very efficient when it comes to flatten the view hierarchy. So as you know, on Android, the less the better. So the less view you have, the better it is for the rendering pipeline, because it will have less work to do. So using drawable, as I said at the beginning, is great when you just want to draw something. So just by removing or getting rid of all of those views that are actually just here to render something, and by using drawable instead is really awesome. And let's start with an example. So here I've used, I want to create that kind of screen. So what will I do? Well, first I will create an Android manifest.xml file. In this Android manifest, I will create a new activity which has a name here, login activity. It also has a label and a theme. And in this theme, I want it to be theme.holo.light.no action bar, because I don't want the action bar. And obviously, and after that, I also have the intent filter. That is basically the intent filter that you have to use when this is the first activity that is started by the launcher. Then I create a layout. And here, I don't know if, yeah, it's big enough. So basically, here is what I have, a frame layout, which match the parent and has a background color. It also has some padding. Then I have an image view that is in the middle of the screen that represents, the logo of the company. And at the bottom, I have a linear layout that contains two buttons, the sign-in button and the sign-up button. Quite simple. But actually, if you look closer to that, here what I do is that I'm using a frame layout for almost nothing, because this frame layout is only used to draw a color. So maybe we can get rid of that. The logo also can be considered as a background. It's not really the content. You can't interact with it. Why do you need to use an image view for that? I don't know. Maybe you can get rid of that too. And finally, there is the sign up and the sign in buttons that are actually the only content that can be controlled on the screen. And the funny thing is, if I start this actually on my device at the startup, here is what I will have, and it will almost instantly fade in to this screen. So I don't know if you can see the animation. It first displays that, a white screen, and then it fades to this screen. And this is actually because Android will actually use a theme of your activity, here the login activity, to extrapolate, to infer the theme and the design of your screen. So as I said earlier, we're using the theme.holo.light.noActionBar theme, and because of that, here is what Android can get from the theme. It's just a background white color, and then it fades to this screen. So we can do way better than that just by flattening the view hierarchy and by optimizing the startup rendering by using a drawable-based beta solution. So what can we do? Well, let's go back to the layout that we'll be using in this screen. So I'm basically getting rid of everything that is not necessary. So as I said, the frame layout was not necessary because it was just displaying a color. The image view was, to my mind, not necessary either because it's actually the background. You really don't care about the image view. It's something that can't be interacted with. It's just something that has to be drawn as the background. So what I have here is basically just a linear layout that is matched on the width and has a 48 dp height, and then its gravity is set to the bottom so that it displayed at the bottom of the screen, and it contains obviously the sign in and the sign up buttons, and that's it. That's everything I need in this screen actually as part of my layout. And now what I do is that I create a drawable which will act as the background of my screen. And here, what I want to do is to layer some stuff on top of each other. So what I'm using basically is a layer list, so a layer list drawable, just by using the layer list tag. And in this layer list tag, I have several items. The first item, of course, is the color, the background color. So once again, I've used the trick that I've previously mentioned, which is to use a shape drawable, but actually, because you are filling the entire screen, you could use a color drawable. And then, on top of that, I have a bitmap, which is centered in the middle of the screen, and also have a bottom inset. And this bottom inset is actually the height of the two buttons, sign in and sign up, so that the image view is centered in the remaining portion of the screen, not in the entire portion of the screen, in the portion between the status bar and the sign in and sign up buttons. And that's pretty much it. Just by creating this drawable, I have all of the design I've previously showed you at the beginning of this example. Now I'm going back to my Android manifest.xml, and what I do here is that I just create a new theme, and this theme here is what I called it theme.default.noActionBar, and this is this theme that we'll create in the res.values directory and in the themes.xml file. And what this theme is just using the theme.allo.light.noActionBar theme as the parent, and it is changing the window background to the drawable that we've created earlier. So the one with the background color and the image, the logo of the company in the middle of the screen. And just by doing that, just by adding, I don't know, maybe 10 lines of code, I've changed the startup of my application. So whenever I'm starting the application, the time that Android requires to start up your application, it will display that. So from a user perspective, this is way better than just displaying a white screen and then fading to another screen. Actually, here you will have like a subpart of your screen, which is the background color and the image of the company, and then it will fade to this screen. So the startup, experience is way better just by using the drawable as the window background. So you have that, and then you fade to that so that the user can sign in or sign up. So this is really something that you can use because it will minimize your layout. So you will do less. So it will be better for the rendering pipeline. Maybe you will have 60 FPS thanks to that. And also it will hugely improve the launching animation of your application. So I think we're at the conclusion of this. So I've not talked here about the fact that you can create custom drawables, but because this is something very simple, you just have to extend drawable, and you have, I think it's 4 methods that you have to override because they are abstract, such as the set color filter and get opacity and stuff like that. But basically, whenever you want to draw something on screen, but you don't care about the measurement and the layout, because this is done by another component like a linear layout or a view, then you have to think about view, because you have to think about the drawable, because it's really made for that. It's only made for rendering something on screen. So as I said, drawables are lightweight. They share constant state between each other. So whenever you're trying to load a resource with a drawable from your res folder, the system will automatically try to reuse the drawable you've already loaded previously. It's system cached. So as I said, if you're using a button, for instance, the regular button from the framework, you have nothing to do, and it won't take memory inside your process because all of this is shared among all processes. Obviously, because it depends on the resource mechanism, loading mechanism, it's configuration dependent. So you can basically have a drawable that is only for French, another one only for English. Well, most of the time, this is not a good idea to have, localized images, but you can, for instance, I don't know, have a drawable for the portrait orientation and another one for the landscape orientation. As you've probably noticed in this presentation, it's also very easy to use. Just one method, get drawable, and then everything works. And from my point of view, it's insanely awesome. So do not be scared about them. Use them. They are really powerful, and they can make your application way better. And that's pretty much it. So if you have some question, thank you. I think there are some mics up there, but yeah, I don't know. No questions? Okay. So thank you very much.